Hi everyone. This is the Big Ideas session for section 2.2. This video is replacing our class meeting on Wednesday, February 10th. So you can just watch this on your own time. You can watch it during our regular class meeting time if that's convenient for you or earlier. Just make sure that you submit your solutions to this worksheet by our regular 8 p.m. deadline on Wednesday. You can always submit earlier than that if you like. This big idea worksheet will be worth 10 points instead of the regular 5 because it will also include your attendance points for that February 10th date. All right, we're going to do a lot of stuff with the calculator today, so make sure you have that ready to go. All right, so the first problem that we're going to talk about from section 2.2 is using first differences to determine if data is linear, nearly linear, or nonlinear. So when we talk about first differences, we're talking about looking at the y values or the outputs of data that are next to each other and finding the difference between them. One condition that you want to double check first before you calculate first differences is that the x values are equally spaced. And our x values here are just counting by ones, -2, -1, 0, 1, 2. If they weren't, we wouldn't be able to use this method to determine what kind of data we have. All right, so when we find first differences, we're going to take two values of y that are next to each other, consecutive, and we're going to subtract them. And we're going to do the later one minus the earlier one. So we're going to do, in this case, 18 minus 15, and that gives us 3. Here we're going to do 15 minus 13. That would give us 2. 13 minus 8. That would give me 5. And finally, 8 minus 5, and that would give me 3. So my set of first differences, let me get my highlighter here, is 3, 2, 5, and 3. It's not exactly linear because they're not the same value all the way across, but these values are close. We've got a couple 3s, 2's a very near integer, as well as 5. So we're not ready to say that this is not linear. Instead, we can just say it is nearly linear. Again, because those values aren't all exactly the same, but they're close. Okay, so let's look at another one, number or letter B here. So again, I want to double check my x's. I've got 3, 4, 5, 6, 7. All of those x's are consecutive values, so we can find our first differences. To start, we're going to do -1 minus 2. Be careful when you have negatives. You might want to use your calculator. These ones, sometimes it's easy to make a silly little algebra mistake. -1 minus 2 is going to give me -3. 2 take away 0 is going to give me 2. 0 take away 7 is going to give me -7. And finally, 7 minus -3, I'm going to write that one out. When we have a minus and negative, we know that's a plus, so that's going to give me 10. So let's look at our set of first differences here. We have -3, 2, -7, 10, and you'll notice that these numbers are kind of all over the place. So definitely not exactly linear. I wouldn't even say that this one is nearly linear. We would say that this is a non-linear set of data. Okay. Finally, let's look at C. So again, we've got all of our x values that are consecutive. Notice in this problem and the last one, they're not saying y. They're giving us that function notation that we practiced. So this is function g that we're going to look at for this example. All right, so I have -4 minus -1 first. So remember that means -4 plus 1, which is -3. Then I have -1 take away 2. That's -3. 2 minus 5, -3. And 5 minus 8, -3. So let's look at those first differences, and hopefully you're seeing a pattern here. We have a lot of -3. So if you get that same first difference, no matter which consecutive set of values for the function that you are finding the difference of, we say that the data is exactly linear. So we should expect then if we graph this data, if we look at a scatter plot, it would make a perfect line is what that's telling us. If we looked at data set A on a graph, it would be a line, but there might be a data value or two that doesn't exactly fit perfectly. And if we graphed B, they would kind of be all over the place. We wouldn't see a line shape at all appear with those data values. So that's another way to check if you're not sure. All right, let's move on to question number 2. All right, so for these examples, we're looking to see if the following sets of data that are graphed or described are continuous or discrete. So let's just kind of talk about again what those definitions are. If we're looking at a graph of continuous data, it means you can trace the whole graph with your pencil without picking up your pencil. It also means that there's no gaps in the data. If we can't trace it with our pencil without having to pick it up, or we do have gaps in the data, we say that it's discrete. So let's look at A. I'm going to try to trace it, and I'm going to get a different color here. I'm going to trace it in green. All right, so I'm going to start from left to right, and I am able to trace that entire function, f of x, without picking up my pencil. I also see as I continue along that graph, there's no gaps in the data. So we would say that this is continuous. Okay, let's look at B. Let me get a different color here. Again, I'm going to trace it from left to right. And I am able to trace this without picking up my pencil. There's no gaps in my data, so it is continuous. Let's look at our third one. Oh, it looks like we're missing our letter C there, has disappeared. I don't know how that happened. There we go. Okay, and here we have a scatter plot. So if the values are not connected already for you, you are assuming that you're not going to be able to connect them on your own. We don't put in lines between graphs or points of data unless it tells us to, or it explains that the graph is continuous. So this is not something I would be able to trace. There are gaps between each of these points, so we say that it is discrete data. Okay, so any scatter plot you have, if there's no lines between those points, you have discrete data. Now let's talk about the described set of information here. Another way to think about discrete data, get a different color, there we go, is it's something that you can count, okay, and again, it has gaps. Okay, so for example, if I asked you age of children, your answer would be 1 or 2 or 3 or 4 or 5. We wouldn't have a child that is 3.4682 years old. We would consider that discrete data because there's only a certain set of numbers, our counting numbers, that would represent that information. Continuous data is not something we would count. There would be an infinite number of possibilities to represent the data, and there wouldn't be values between other given values. It would be able to be represented on a graph with a line. Okay, so let's look at D. It says the number of customers who bought different items. So you want to ask yourself, could I count that? Yes. Could I have partial customers? Could I have, let's say I have 2 customers, 8 customers. Could I have 4.5 customers? That doesn't make sense. So we definitely have gaps in the data between our numbers. It's something we can count. So we say that this is discrete. All right, let's look at the next one. Computers with Windows 10 in each classroom. Again, is that something we could count? Yes. Are there gaps in the data? Could I have half of a computer with Windows 10 on it? No. So this is discrete data. Okay. Next, the temperature of a freezer. So is it something you can count temperature? No. Could I have partial temperatures? Could my temperature be 37.5 degrees? Absolutely. So we say that this is continuous. Again, not something that I can count. Okay, let's look at G. It says your total bill at the grocery store each week. So maybe my bill is $200 or $250. Or if you're really a super saver, maybe $80. Could I have values between that? Yes. Could I have $167.25? Yes. Could I have $167.26? Yes. Could I have a value between those? No. So is this something we can count? Well, we probably don't want to count it, but it is something we can count because you're limited to dollars and cents for these. So this would be discrete data. We're not going to have partial cents. Weight of a newborn baby. So when we talk about weight, is that something that we could count? Not really. Is that something that we could have partial values for you? Can you have part of an ounce? Something like that? Absolutely. So we would say this is continuous. Okay, and not something we can count there. Last one, the wind speed on February 10th, maybe the day that you're watching this video. Can we count wind speed? No. Could we have wind speed that is a partial mile per hour, 4.2 miles per hour in the southwest direction? Sure. So that is continuous. Okay, so that's maybe the easiest way to look at these ones that are representing certain set of data. If you know what it represents, could you count it? If the answer is yes, it's discrete. Could you not count it? Then the answer is continuous. All right, let's move on to number 3. All right, so this is a calculator problem. We want to know which line is a better fit for the data. So we did this in a previous section. The first thing we're going to have to do here is find the line of best fit. So let's go ahead and bring my calculator up here. All right, so let's review the steps to putting data in our calculator. And I know some of you have needed these steps repeated, so it's the beauty of a video right now is you can always pause it and rewind if you want to see the steps one more time. All right, so we're going to hit Stat right next to our arrows. We're going to go over to, well, actually, we're going to edit first. So let's just hit enter for edit. And then you probably have some data in here from previous lessons. So we're going to go up, hit clear, go back down, up, hit clear, go back down. All right, so in L1, we're going to put the average temperatures. In L2, we're going to put the average number of rainy days. All right, so this will be the little tedious part, getting all this data in there. Make sure you're following along with this in your own calculator, not just watching me do it. The only way that you're going to get efficient with this process is by doing it yourself and practicing. You don't want to find out on test day that your calculator is giving you some sort of error when I am not available to help you. Okay. So once you have all the data in here, you want to double check at the end that you have the same number of values in L1 and L2. If you don't, you want to go back and look at your data one more time and make sure that you didn't miss anything, because if you've got an extra value in L2, for example, your calculator will begin to give you an error if you want to see the graph for this. If you don't have your data in there yet, just hit pause and then hit play when you're ready to go. All right, so the next thing we want to do is we want to take a look at this data. To look at this data, we're going to go into y equals. And remember, if we want to see our scatter plot, we want plot on. Any other time with your calculator, you want plot off. So we're going to go up to plot 1 if it's not already on, and turn it on. And then if you remember, zoom 6 is our regular window, and zoom 9 is the other one we've used a lot. Zoom 9 will be zoom stat. It'll zoom in on whatever statistics you have. And there is the picture of the data that is represented with this chart. Okay, so we're looking for which line will be the best fit for the data. So Depending on what version of the calculator you have, you can graph all of these at once, you can graph one at a time. I'm just going to graph one at a time and kind of drag them over, and then we'll compare the 4 pictures that we have. So my first one is going to be negative 0.5x plus 5.4. Remember, you have to hit y equals to get into there. Make sure you hit the X button that's right next to alpha. And then if you hit graph, you'll see that line graphed with that data. Okay, so let's drag it over. All right, so that's A. Let's go ahead and do the same things for B, C, and D. So again, we're going to go to y equals. I'm going to clear out what's in B, and I have negative 3x plus 10.1 I'm going to put in there. Again, that's option B we're graphing now. Hit graph, and you'll see that line graphed with the data. Okay, drag it over on mine. There we are. All right, so we've got A, we've got B. Okay, let's go ahead and do C. So again, back to y equals. Clear it out. Negative 0.3, and I'm not putting the 0 in there because it's to the left of the decimal, but if you guys are putting it in there, that's fine. X plus 12.3. Graph. Okay, so there's C. And then let's go ahead and look at that last one. That one up there. Okay, so back to y equals. And we're going to type in negative 0.7x plus 13.5. Hit graph, and there's our last picture. All right, so the question is asking which of the following lines is a better fit for our data. So let's go ahead and label these so you have them. This guy was A, B, C, and D. The line that's the best fit of the data will show the general trend of the data. It should go through the middle of the data if your data is not exactly linear, with approximately the same number of points above the line as below the line. So hopefully you're looking at this and saying, well, B and D look pretty off. It doesn't look like it's going through those data values. So we're going to go ahead and eliminate those. Then I want to compare A and C. I'm nearing towards C. Looks like it's going to be a better answer here for a couple reasons. First of all, my line is going through 3 of my points, which is great. But then also I have, looks like 5 or 6 points below and 3 points above, versus if I look at A, I have 3 points above, none on the line, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 points below the line. So that line looks like it's a little high for the data that's being represented. So we're going to say that the best fit for this one is C. Okay. If you're getting any sort of calculator errors here, I suggest watching this problem through one more time and make sure your settings in your calculator look the same as mine. If you're still having trouble, feel free to reach out to me via email and I'll see if I can help you troubleshoot a little bit with your calculator. Okay, so our last problem today is another data question. So again, we're going to have to get this data into our calculator. So we're going to practice that process one more time. Stat, edit, hit enter. We're going to clear out our list. So we're going to go up to the list name, hit clear, go back down. Up, clear, go back down. All right, so square feet is our x's. Let's get all that in there. Okay, so I had 10 square footage values. Let's get our house price. Now the house price is represented in thousands, which means technically that 245 represents $245,000 is the value of the house. The reason we're not putting all the zeros at the end of it is because when we get an equation, our equation gets a little messy with the decimals. So it's easier to just use the hundreds values because everything that we have here would have 3 extra zeros added on to the end of it. It's easy to cut those off and just get some smaller numbers in our equation, easier to do calculations with. So look for those in the title of tables. If it says, you know, thousands or millions or something like that, it just means each value's got some extra zeros at the end of it in real life. Okay, so again, double check that you've got 10 values in both your L1 and in your L2. If you don't have your data in there yet, hit pause, and then you'll be ready to move on to the next step. Okay, the next thing we're going to do with this equation is we're going to find the line of regression in the correlation coefficient. So you can actually find both of these, part A and part B, the same way. At the same time, but you needed to make sure that your correlation coefficient, your data settings is set up in your calculator. Now this was part of the Edpuzzle video. Once you turn it on once, it'll be on forever. So those of you that watched the Edpuzzle video already and you were getting R values as you were watching that, you're good to go. But maybe if you haven't watched the Edpuzzle video yet, you're going to hit mode. Okay. And let's see here. We're going to go all the way down. Mode was right next to second that I hit. And the one we're looking for is towards the bottom. It says Stat Diagnostics. So we want Stat Diagnostics to be on instead of off. So if yours is off like that, you're just going to go over to the word on, hit enter, and you now have your Stat Diagnostics on, and your R's will show up forever until you decide to turn that off. But that's not anything that's going to hurt any other type of equations that we've done, so you can just kind of leave that on. All right, so once you've got your Stat Diagnostics under mode turned on, just hit quit to go back to your home screen, second mode. All right, so let's go ahead and find that line of regression. We did this in the last chapter. We're going to hit Stat, Calc, and then linear regression, line of best fit, that's number 4, the one we're looking for. And that AX plus B, remember, just means like MX plus B, or slope-intercept form of a line. Okay, so we've got L1 and L2 in there. In none of these problems do we have to actually graph this scatter plot for right now, so and the line of best fit. So for right now, we're just going to leave that there. Well, you know what? Let's throw it in there just in case. Maybe we might want it a little bit later. All right, so let's put it in y equals for us. We'll practice that step. So we're going to hit vars, go over to y vars, function, and y1. Okay, so I was under the store regression equation, and again I hit vars, then go over to y vars, then hit function and y1. You can actually hit any of the y's, that's just the equation it'll show up on, and then hit enter. And your calculator should spit out values that look like this. So now everybody should be seeing those R values show up that you maybe didn't have before. Okay, and we want to, I'm just going to kind of put that over my data there. We want to write our equation. Now, if you weren't able to get your equation to store in y equals, if anybody's still having trouble with that, remember that's not mandatory. You can always type your equation in y equals if you want to see the graph of it. So we're going to round here to the nearest thousandth, 3 decimal places. So my first value A, 0.109, I look at the number after that, it's 7. So that tells me I'm going to round up. So that's going to round to 0.110. That 9 is going to round to a 10. Then I've got the X plus my B value, 98.248. And that's my regression equation, my line of best fit. Correlation coefficient is your R value. R value here is 0.762, again, rounding to 3 decimal places. So what does that mean? All right, so again, referring back to the Edpuzzle video, there were different values we have for R. They range from -1 to +1. -1 means you have a perfect set of linear data, a line going down. +1 means you have a perfect set of linear data going up. And then if you have an R value of 0 right in the middle of those, that means that your data has no correlation. It's kind of all over the place. So then anything between -1 and 1 means you don't have a perfect set of linear data, but it might be nearly linear or approximately linear. It also tells us if we have a positive or a negative correlation. Because my R value is a positive number, that tells me I have a positive correlation, which for this data would mean that as the square footage of a home increases, so does the house price. As one goes up, the other goes up. An example of negative correlation would be as one goes up, the other goes down. So for example, if you had termites in a home, the more termites you have, potentially that would be lowering your house value. So that would be an example of negative correlation. One goes up, the other goes down. Okay, so we know it's positive. We don't have a number very close to 1. If you had something close to 1, it'd be like 0.9 or 0.95. Because it's a little lower than that, we're going to also say that the correlation is a weak correlation. It's not strong. If you looked at the scatter plot, which we'll do in a minute, your data is not going to really make much of a line, but you could see a general trend going down at least. Again, if you had a number like 0.9, 0.95, something a little closer to 1, or -1, if it was negative, we would say that there was a strong correlation. All right, let's look at C. C says estimate the price of a home that is 2,100 square feet. Okay, so you can do this from your equation by plugging 2,100 in for X. You can also do it with the graph, but let's go ahead and practice with the graph. We already had that equation in y equals, so might as well use it, right? So let's hit y equals. If you don't have your equation stored in there, again, no big deal. Just pause the video real quick and put your answer for A in your Y1. And also everybody's plot should still be on here. Remember, we have to hit zoom 9 again. You've got to hit zoom 9 every time you have a different set of data, because you have a different set of values that you are graphing. All right, so again, we're seeing our line with it, which is awesome. You can see that line is showing the general trend of the data. It's going through a few points. There's approximately the same number of points above and below the line, so that's great. All right, so we're estimating a home that is 2,100 square feet. So we've done this before. We're going to hit second trace. We're going to go into that familiar calculate menu we've seen. We've done mins, we've done maxes, we've done zeros, intersects. So we've also done value, but this was a little while ago. So we're just going to hit number 1 for value. And we want a value when our square footage, or our X, is 2,100. So we're just going to type in 2,100 and hit enter. And what we see for y there is our answer. So I'm going to round to the nearest whole number. 329 is the value when x is 2,100. So what does that mean? That means when we have a 2,100 square foot home, the value of our home is approximately 329,000. Remember, everything was in thousands, so we're going to add those zeros on at the end of it. Make sure you label all of these. This is dollars, so $sign. And that would be the value of our home for that square footage. The second part of this question is it extrapolation or interpolation? We'll start with interpolation. Interpolation means we're looking at a data value that is within the data values we were given. Extrapolation means we're looking at a data value that's beyond the original data values that were given. So if we go back to the calculator, you can see where your little blinking cursor is located. That's within the original picture that I had. It's between sets of the data here that we were given to start. So that means that this is an interpolation that we're calculating here. Okay, so let me circle that. It's within the data values we were given to start. All right, so let's go ahead and do it again. It says estimate the price of a home that is 3,000 square feet. So we're going to hit second, calculate. Again, we want a value, and we want 3,000 this time. And it's telling me I have an error. Now, why is it telling me I have an error? Because 3,000 is not in that picture. So what we can do is, let's see here. Oh, sorry guys, hitting the wrong buttons. Okay, so we got that error for the 3000. So let's go ahead and adjust our window. The reason we're getting that error is because 3000 is beyond the data that we're given. It's not in the picture that we've zoomed in on. So we've done this before. If you hit window, you can see what your calculator has used for your x's specifically, or what we're looking at here to zoom in on. So right now our x-axis is going from about 965 to about 2600-ish. So that makes sense that we can't see the 3000 value because it's only counting up to 2600. So if we go down to X max, you can change it to whatever you want as long as it's a value bigger than 3000. So I'm just going to choose 3100, but if you chose like 4000, for example, that wouldn't affect your answer. Now if you hit graph, you'll see that it's zoomed out a little bit further on the right. So let's try that procedure one more time. We're going to hit second, trace, value, number 1. And now let's try 3100 again. Enter, and you can see we've got for 3100 our y value is about 438.5. So again, if we round to the nearest thousand of dollars, we've got 439,000 would be the price of that home, approximately 439,000. Okay, now this time the data value we said was beyond what we were originally given, which is why we had to change our window. So that means that this is extrapolation. So that's going to be a big clue for these. If you have to change your window to find the value, it's extrapolation. If you don't have to change your window, it's interpolation, more than likely. The other way to do this that we've talked about before is you can go into the table of values and you can just scroll up and down until you find the value that you're looking for. All right, so the last problem is we are trying to estimate the square footage of a home that is worth 295,000. So there's a few different ways to do this. One way is you could trace values on the graph itself. The other way is with the table of values. Now here, if we know the home value is 295, that means we're given the y, and we're looking for when y is 295. The square footage is our x, so we're finding the x that goes with that. Okay, so with our calculator, if we want to do it with the table of values, we could just start scrolling right now. Now this means we have a square footage of 17 square foot, 18 square feet, so on and so forth. You can see this is maybe going to take a while to get to 295. So if we want to jump a little bit in our table, we can hit second, window, and we've done this in one of our big idea sessions before. This is our table settings. You can make your table start at whatever you want. So I'm going to make my table start at, well, let's look at our data here. Let's try to take like an educated guess of where we think it might be so we don't have to scroll too long. All right, so we're looking for when y is 295. I've got values kind of close to that. Oop, why did that go back up there? Stay down there. All right, so I've got 279 is when it's 1700. What else do I have? 255 for 1700. I've got 319. I've got let's see if I've got anything else. 245 is 1400. Maybe let's start at like 1500 and just see what that looks like, kind of in the middle of the 14 and 17 that we're seeing. All right, so we're going to make our table start at 1,500 square feet, and you can make it count by ones if you want, or you can count by tens or something like that. So again, you don't have to scroll as much, and then you could change it. Typically, the default here is that our table start is 0, and then triangle TBL means change in the table, what it's counting by 1. So 0 and 1 are kind of like the defaults you could set it back to. Again, to get to this menu, we hit second, window. That's it, and make your table start a value where you think that might happen. So 1,500. So now let's go to table, second graph, and we're looking for when we hit 295. So let's see, it looks like I'm still a little off. Let's go to like 1,700. Okay, and again, you can just keep scrolling if you want. I don't like scrolling forever, so I'm just going to kind of jump around in this table. All right, 1,700, we're a little bit closer. We're looking for 295. We're getting there. almost there. There we go. Looks like the first time we hit 295 is when we're at 1793. So we're going to say 1793 is the square footage that we're looking for. Now, both of these problems, actually all three of these problems, C, D, and E, you could also use the equation to help you if you want to solve it algebraically, like we did back in the last section. For part C, in your equation, you could make x equal 2100 and solve for y. In D, you could make x equal 3000 and solve for y. And in E, you could make your y equal to 295 and solve for x. So we're using technology to get these, but you can also solve it algebraically as well. Obviously, on a test or a quiz, the quiz would be pretty specific about the method that you would need to use, but on the test, you can use whatever method you want because it's multiple choice and nobody knows. So what your work is on those. So whatever you feel more comfortable with. If you feel like you're more likely to get a correct answer by just plugging the value in the equation, do it. If you want to practice with the calculator or you feel comfortable with the calculator, or you feel like the calculator just might be more accurate because you don't have to make those maybe potential silly algebraic mistakes, that's also a possible method. Okay, so that would be the end of our big idea session. So as soon as you guys are done watching this video, make sure you submit this to Blackboard. Please try to submit this as a single file, not like 4 different pictures, okay? Remember, look into apps like Cam Scanner, PDF Scanner. Those are free. If you have an iPhone, your Notes app can make a scan into multiple pages, so it's just one thing that you're uploading. Makes it easier for me to view it, and then there are no errors. I know some people have had errors with just pictures uploading versus a PDF is going to be a little bit better. All right, so make sure you get that up there by Wednesday at 8 p.m. And then for the remainder of the week, you guys can work on your 2-1 and 2-2 assignments in my math lab. This week you also have a extra bonus with solving equations available in my math lab, so it's a good way to get some extra homework points added in, and again, a little extra practice with solving equations. And then finally, don't forget you have your quiz number 3 that is due Saturday evening as well. Feel free to reach out to me via email if you guys have any questions, and I will talk to you soon. Thanks.